Welcome to this new and innovative diesel training course. My name is Carter, and I will be your virtual teacher. Together, we'll make a path that will allow you to learn, understand, and review fundamental information to be able to effectively modify a diesel engine, thus increasing performance in terms of torque and power while maintaining low smoke and environmentally harmful pollution emission levels. Have you ever thought about improving fuel consumption in addition to improving performance? Thanks to our training, this tuning method will no longer be a secret. We will begin to lay a solid foundation to understanding the main parameters managed by the ECU that act on a diesel engine in order to answer very complex questions focused on the world of diesel engine tuning, such as: what are the elements underlying the function of the engine? How does the injection phase work on diesel engines? And how does it affect the ignition of the air-diesel mixture inside the cylinders? How does the ECU correct the injection based on specific smoke thresholds and the concentration of pollutants? In addition to these topics, we will address and examine in detail the various injection systems used by manufacturers over the years, and we will study the maps used by the ECU to manage each system together. We will start from the primordial system that used a simple injection pump connected to the distribution, and then see in detail the innovations brought about by the injector pump system. And finally, the system most used by manufacturers from the early 2000s to today, the common rail system. After these first steps, we will prepare for the more complex topic of the training course. Don't worry. There is nothing you can't learn with my help. We will first take a look at the control strategies implemented by manufacturers of engine control units to be able to reduce polluting emissions based on the requests made by the Euro or Tier regulations, and then how to manage performance and consumption. Also in this case, we will start from the simplest strategy and then get into the more complete and complex one, the strategy based on internal torque calculation. Now let me explain. The simplest strategy bases its operation on direct fuel management according to the percentage of activation or pressing of the accelerator pedal and the engine revolutions. This is simply called the fuel control strategy, precisely because all the main management maps are based on the amount of fuel injected and the engine RPMs. Increasing in complexity, we will find the strategy called mass flow metering, also abbreviated with the acronym MFM. This takes its name from the main sensor used to determine the flow of air entering the engine. The mass air sensor, MAF, which allows the engine control unit, after performing the appropriate calculations, to command the injectors to inject the correct dose of fuel for each cycle and thus maintain the air-fuel ratio set by the manufacturer so that black smoke or high quantities of nitrogen oxides are not developed. Continuing to follow this same strategy, we will examine in detail the more or less complex calculations that the control unit performs to represent other very important parameters for the correct function of the engine, such as the air load, the inlet air mass, and finally, the air density. However, this strategy was used for a short time and only for large displacement diesel vehicles, precisely because of its low accuracy. Therefore, we will dedicate the rest of the training course to talking about the most recent engine management strategy used by manufacturers, the one based on the torque calculation. For the torque calculation strategy, slightly more complex compared to the others, we will perform a detailed examination of its operation from the base or from the main map through which the torque request is made according to the percentage of the accelerator pedal pressed and the engine speed, up to the management of the various actuators, such as the high-pressure pump, the variable geometry of the turbine, the injectors, or even the EGR valve. In addition to its operation, we will also take a look at the disadvantages and advantages that this strategy has provided, the calculations performed by the control unit to efficiently control the performance delivered, and finally, its natural evolution, torque monitoring. the torque monitoring strategy can be defined as a simple torque calculation, but with some additional complications since this additional control is added to the engine protections, such as the torque or fuel limiters, in order to verify whether the calculated engine torque is consistent with the true engine torque generated. For this latest generation strategy, we will analyze its shape and the possible maps that are used to manage this control. Finally, we will take a look at some potential real situations that can be found within the original files and how to manage these to be able to disable monitoring and not experience any limp mode problems or DTC errors in the diagnosis. How could we conclude our training course, however, without putting into practice all the notions we have learned? After learning the operation of the diesel engine and the management performed by the control unit, we will then apply the concepts learned together in 3 specific practical cases which base the performance control strategy on the calculation of torque, but which comply with different emission regulations, respectively Euro 5A, Euro 5B, and Euro 6D, Temp Evap ISC. In addition to this, for each practical case, we will illustrate the technical characteristics of the engine, and we will take a look at the models of the main components used within the engine system, such as the high-pressure fuel pump, turbine, and injectors to better understand the mechanical limits of the latter, or easily check whether another vehicle uses the same components. The first example is based on a 66 kilowatts Volkswagen Polo V 6R 1.6-liter TDI with a Continental PCR 2.1 control unit with a slightly different map structure from the 2 following examples. This is because the manufacturer of the engine control unit is Continental and not Bosch. Here, we will go into specifics to understand how to modify the engine torque category in order to reach higher values than stock units. We will also learn how to correctly modify the maps that define the targets for the actuators and thus be able to achieve the required performance. Finally, we will discover how to unlock any limiters, such as the speed limit, or linearize some corrections made by the ECU which could reduce the torque delivered. The second example was built on a 103 kilowatts Volkswagen Passat 7 2.0 TDI Blue Motion and equipped with a Bosch EDC17C46 control unit. The file structure is slightly simpler compared to the example defined before, since the control unit manufactured is Bosch. For this reason, we will find many other original files, even from different manufacturers, with the same structure and the same type of maps. Also in this case, we will start with the modification of the torque category, then move on to the other categories and set the targets for the actuators, mainly the injectors, the high-pressure pump, and the turbine. To conclude, the last example is based on a latest generation engine, 3.0 TDI EA897 Evo 2, mounted on the 210 kilowatt Audi A7 C8 Sportback 50 TDI MHEV. The file structure will allow you to put into practice all the notions learned since the MD1CP004 control unit installed in this vehicle is the latest generation developed by Bosch. We will, therefore, see that it will be necessary to modify many more parameters compared to the examples defined before, specifically because the manufacturer has implemented several protection and engine management maps. In addition to this, the engine analyzed is equipped with a mild hybrid system, so we will find some maps dedicated to managing the electrical part available for modification. Good! We have seen the topics that we will cover in this fascinating journey. So, what are you waiting for? If you want to become a professional tuner, continue with the next videos. And don't worry, I'll be there to guide you step by step.